The difference quotient. The difference quotient for the function f of x is f of the quantity x plus h minus f of x all over h, provided h does not equal 0. The name difference quotient describes what we see, the difference of two terms, and a quotient. Let's take a look at what this represents. Let's go ahead and focus in on this graph. This red curve here is the function f of x, and we're going to go ahead and focus on a generic point on the red curve, and that generic point is going to be the point x, f of x. So here I'm going to label this coordinate point x, f of x, and then we're going to go ahead and pick another point on the curve that is a distance h away from x. So this is some generic x value. We have a distance h away, and in this case h is positive. So then this new coordinate point up here is the point x plus h, comma, f of x plus h. So it's just two really generic points on some function, on some curve in this case. So now, well, what is this difference quotient? This difference quotient is representative of the slope between those two generic points. So if you recall, the slope between 2 points is found by subtracting the y values divided by subtracting the x values. So in other words, we would have f of x plus h minus f of x, so I'm subtracting the two y values, all over subtracting the corresponding x values. So we have x plus h minus x. And so the x's cancel, so we have plus x minus x, and what we can see now is this difference quotient. So the difference quotient is really just a slope between 2 points on a function. And if we have 2 points, those 2 points define a line, and that line has a special name called the secant line. In this example, we want to find the difference quotient for each of the following. Simplify by canceling the h in the denominator. So let's remind ourselves what the difference quotient is, and I'm going to color code this here. So I'm going to put f of x plus h in purple, and then minus, I'm going to put f of x in blue, and then all over h. The denominator was simply h, which I'm going to write in green. So I really want to think about this as 3 separate pieces here. This difference quotient, I want to think about it as 3 separate pieces. So find the difference quotient for this particular function, f of x equals 3x squared minus x. So if I think about this in 3 pieces, I have one of those 3 pieces exactly. This top right hand side, f of x, is 3x squared minus x. So what I will eventually do is replace this generic f of x right here with 3x squared minus x. But I also need f of x plus h. So before I even get started with replacing these pieces here, I'm going to go ahead and do some scratch work and first find f of x plus h. So f of the quantity x plus h is found by replacing each x in f of x with x plus h. So a lot of students get confused because of how this looks. So if we were finding f of 2, we would simply plug a 2 into each x. We are finding f of the quantity x plus h. So same concept, we're just going to plug x plus h into each of these x's. So it's going to become 3 times the quantity x plus h squared minus the quantity x plus h. So I have replaced each x with x plus h. All right, now I'm going to go ahead and distribute all of this out. So this is going to be 3 times x plus h times x plus h minus x minus h. So here, let's remember, I cannot distribute an exponent. That's not a thing. It's a very common mistake. Here, I am distributing the negative to each term, so I want to be careful to, and make sure to do that, minus x minus h. Here, what I have to do is think about it as quantity x plus h times quantity x plus h. So we have 3 times, here I have to distribute, so x times x, that's x squared. Outer is xh, so plus xh. Inner is hx, which is the same thing as xh because of the commutative property. I could switch their places. So I've done first, outer, inner, and last is plus h squared minus x minus h. And then this 3 can distribute to everything in here, but let's go ahead and notice that inside right here, plus xh, that's 2xh. 2 copies of x times h. So this 3 will distribute, and what are we looking at? 3x squared plus 6xh plus 3h squared minus x minus h. Ooh, so quite a bit of algebra that we have going on here, right? But not too bad. Just really want to be careful about parentheses and distributing. So now this whole thing right here is going to replace the top left part of the difference quotient. So again, it helps if I think about it in these 3 separate parts. So the top left, f of x plus h, is this big thing right here. 3x squared plus 6xh plus 3h squared minus x minus h. All of that is going to go in this top left-hand corner. Then we're going to have f of x in the top right-hand corner. And f of x is 3x squared minus x. So that piece is going to replace the top right. And then all over, just h. H is nice. We don't have to do anything with it. So let's go ahead and start to fill it in. I'm going to put a big fraction bar. And again, I'm going to use purple. I'm going to put 3x squared plus 6xh plus 3h squared minus x minus h. So all of that minus, and what comes next is f of x. Well, f of x is a binomial. It's 2 terms, so I have to keep it in parentheses, 3x squared minus x, because this negative is going to distribute, and then all over h. So here again, those 3 parts, I have this whole thing on the top left right here. This is f of x plus h. Then we have minus our f of x is next. All of this right here is f of x. And then over h. So at first, students kind of are thrown off by this. This is definitely something that's different. But once you see it, once you can sort of visualize the replacements that we're making, then we just go ahead and substitute those in. And a lot of stuff should simplify and cancel out on this one. So here, let's see, I'm going to go ahead and copy 3x squared plus 6xh plus 3h squared minus x minus h, and then minus 3x squared plus x after distributing in that minus there, and then all over h. So what should happen if I've done things correctly is everything in the numerator should cancel that doesn't have an h in it. So we are told in the instructions, simplify by canceling the h in the denominator. So eventually the goal is I want to cancel out this h in the denominator. Now, first things first, one of the super common mistakes is an algebra mistake more than anything else, is that students are like, oh, okay, I'm just going to go ahead and cross out an h here and here. Can't do that. I can only cancel when I have terms that are being multiplied, right? So here this is subtracted, so I can't cancel. They're not factors that I can cancel if they're not multiplied. So here that's a super common mistake. I can't do that. What I have to do is, again, recognize that I have some terms that add to 0. 3x squared minus 3x squared adds to 0. Minus x plus x also adds to 0. So what I have left in the numerator is 6xh plus 3h squared minus h, all terms involving h. And that's what we want, because then what we can do is factor out an h. So again, I can't just cancel these h's here. People will do this first step and then still go about it wrong and cancel these h's. I can't do that. So I have to factor out the h that is in common, h times 6x plus 3h minus 1 all over h. And now that I have made it a factor, these are multiplied, now h divided by h can cancel because h divided by h is just 1. So what I have left is 6x plus 3h minus 1. And all of these were equal to the previous line. So sometimes I hesitate to write equals, equals, equals at first because we always want to be sure that what we're writing truly is equal to the line before it. Even if it is just our scratch work, we want to be really precise and make sure that what we're writing is equivalent to the line before it before we just go down the row and write equals, equals, equals. So this line is equivalent to the line before it, line before it, line before it. After we cancel these h's, here's what we have left, 6x plus 3h minus 1. So how do you know you're done? Again, because we were told that simplifying here means canceling the h in the denominator. So once I've done that, this is going to be my answer. Now I know you might be thinking, okay, now what? What is all this about? Well, the application here comes in the next class in a Calculus 1 course. So right now, this is a precalculus concept, and the application comes in the next course. Let's go ahead and look at another example. We have the function now is p of x equals 4 over x. So we're going to apply the same concepts. The difference is going to be in the algebra. So here, the name of the function is p of x. So the difference quotient would look like p of x plus h minus p of x all over h. Now, once again, I have the function p of x, 4 over x, so I have that top right-hand part of the difference quotient. I need p of x plus h, so I'm going to do some scratch work on this left-hand side to think about what is p of x plus h. So p of the quantity x plus h is replacing the x with the quantity x plus h. So it's going to look like 4 all over the quantity x plus h. So we are replacing any x variable in the original function with the quantity x plus h. One of the most common mistakes is just tacking on an h in the back. So I have some students that, I'm going to do this in red since it's incorrect, put p of x plus h as 4 over x, and then they just put a plus h behind 4 over x. That's a completely different thing. So we're not just adding a plus h in the back. We are substituting in x plus h into the x, which seems weird. We're replacing an x with an x quantity, right? X plus h, but that is the application. All right, so now 4 over the quantity x plus h is the top left part of the difference quotient. 4 over x is the top right side of the difference quotient. So we're going to put 4 over the quantity x plus h minus 4 over x all over h. So the goal now, this is the difference quotient. Our goal is to simplify it by canceling the h in the denominator. So I need to cancel this h. The algebra here is going to be different. Here I have a complex fraction. I have a fraction, 2 actually, in the numerator over h. So I have a fraction within a fraction. So what I want to go ahead and do is in the numerator find a common denominator to combine these two things together. So the common denominator here is going to be found by multiplying the two denominators. So what I'm going to go ahead and do is just go ahead and copy this over. So it's the exact same thing, and I'm going to use a different color to show what's happening here. So I need to multiply the denominator on the left-hand side by an x, which means I have to multiply the numerator by an x as well. So this is x and x. And then on the right-hand side, I need to multiply the numerator and denominator by the quantity x plus h. So it's like I really just multiplied by 1 on the left. X over x is 1. On the right, it's like I multiply by 1. Same thing over the same thing is 1. But now these two fractions have common denominator. So I found the least common denominator. Now I can combine these two together. So I can say this is 4x minus 4x minus 4h. So this negative 4 right here distributes to the x and distributes to the h. So we're combining the numerator, right, subtracting, so minus 4x minus 4h, and then over x times x plus h. So I'm not bothering to distribute in the x on the bottom. I'm just leaving it as the common denominator, x times the quantity x plus h, and then all over that h. All over that h. So we can put equal signs here. Our previous line is equivalent to our following line. And now let's see what happens. 4x minus 4x cancels out, becomes 0. So I have negative 4h over x times quantity x plus h all over h. So this h on the bottom is really h over 1. So I just want to be really thorough about the work that's happening here. So what I'm going to think about this as next is negative 4h over x times x plus h. So that's what's left in the numerator. And instead of dividing by h over 1, I'm going to use the technique where I multiply by the reciprocal, 1 over h. And now I can see that these h's are factors, right? Everything here is being multiplied and divided, so h over h is just 1. So this h and this h cancel because h divided by h is 1. So all I have left is negative 4 over x times the quantity x plus h. So it's not wrong to distribute in this x. If you wrote x squared plus xh, that's fine. But it wasn't necessary. So here we're done because we canceled the original h that was in the denominator. So I know there's an h in the denominator, but we canceled that original h. So this is my simplified difference quotient. Before we move on, this is the same problem. I just want to go over another algebraic strategy for simplifying the same difference quotient. So we could use the process we just did, which was finding common denominators in the numerator, or we can use the technique called clearing fractions. So to clear fractions, we're still going to find the least common denominator amongst all the fractions involved. So that's still x times x plus h. But then what we're going to do is we're going to multiply the top and the bottom of the fraction by that least common denominator of all fractions involved. So I'm going to multiply the top and the bottom by x times x plus h. So this whole numerator and this whole denominator is multiplied by x times x plus h. So this x times the quantity x plus h, it essentially distributes to both terms. So what I can do is think about it like this. It's being multiplied by that first term and over here by this second term. Now since multiplication is commutative, I could think about putting it in the back. That's fine. So what's going to happen here is that this process is going to eliminate all of the fractions that are involved. So here what we're going to see is the quantity x plus h is going to cancel, and here the x's are going to cancel. So top left, top right, we've lost all fractions. So let's see what we have left. We have a 4x left minus, so what's left here is a minus 4 times this quantity x plus h. So minus 4x minus 4h. So again, this negative 4 distributes, and then we have all over x times quantity x plus h times h. And then we can see that the 4x minus 4x cancels. So we have minus 4h on the top, or negative 4h, and then x times x plus h times h. Now that this is all multiplied and divided, we can cancel. H over h is 1. Let's write some equal signs here. These are equal, so we have negative 4 over x times the quantity x plus h. So we have the same answer using a different algebraic strategy. So once you understand the concept, how we're substituting in p of x plus h, substituting in p of x, from there, it's really no longer necessarily precalculus, it's really just the algebra it takes to be able to simplify getting rid of the h in the denominator. In this part, part C, we have g of x equals the square root of the quantity x plus 2. So here, I'm going to go ahead and set up the difference quotient using the function g. So g of x plus h minus g of x all over h. So once again, we already have g of x. We have the top right-hand side of the difference quotient. We need g of x plus h. So I'll do my scratch work over here to make sure I understand that concept. G of x plus h is replacing the x in the g of x function, replacing it with x plus h. So we're going to have the square root of x plus h plus 2. So again, we replaced x with x plus h. So the x plus h is underneath the square root. Again, common mistake, people just putting a plus h in the back. I cannot do that. That's not what is meant by this g of the quantity x plus h. Alright, so now this is my top left-hand corner of the difference quotient. So I'm going to go ahead and put this big giant fraction bar here and plug in my g of x plus h, so the square root of x plus h plus 2 minus g of x, that was given to me, that's just the square root of x plus 2, and then all over h. Now the goal here is to eliminate this h on the bottom. And when I have square roots involved, the strategy that we're going to use is to multiply by the conjugate. So this is just knowing this through practice. The way that we're going to even have something to start with here is using the strategy of multiplying by a conjugate. And how we know to do that is when it involves roots, square roots. So what we're going to do is multiply the top and bottom by the conjugate of the numerator. So the conjugate is simply changing the sign between the two square root terms here. So I'm going to make some space for myself. I'm going to go ahead and multiply by the square root of x plus h plus 2 plus the square root of the quantity x plus 2. And if I multiply by that on the top, I have to multiply by that same exact thing on the bottom, because it's like multiplying by 1. Same thing over the same thing. So we want to be careful here. These are binomials. They're two terms. So we do want to keep parentheses around them. So now what's going to happen when I multiply by a conjugate, something nice will happen. When I distribute, the middle terms will cancel. So here I'm going to show the work, but in general we don't have to, because multiplying by the conjugate is doing this on purpose so that we know automatically the middle terms cancel. But again, I'm going to show this work. Well, the work I'm going to show is that the square root of x plus h plus 2 times the square root of x plus h plus 2 gives us just the part underneath the radical, the radicand. So x plus h plus 2, that's first, multiplying first. Then we're going to go ahead and do outer, right? We're going to do all this distributing. So what we're going to have is plus, I am going to write it all out, as annoying as it is, radical x plus h plus 2 times radical x plus 2. Nothing cancels. They're not the exact same term or square root term. So that's outer, and then inner, when I multiply here, these two terms, I'm going to have minus the square root of x plus 2 times the square root of x plus h plus 2. And then finally last, multiplying these last two terms, I have negative the square root of x plus 2, positive the square root of x plus 2 multiplied. So positive times a negative is a negative. The square roots cancel, and I just have the radicand underneath, which is x plus 2. Since it's a binomial, two terms, it has to stay in parentheses. All right, so what do we have going on? The middle terms there are the same term but opposite signs, plus and minus, but they both have the radical quantity x plus h plus 2 and radical quantity x plus 2. So these cancel out. And as I was saying, we knew they were going to. That's the whole point of multiplying by a conjugate, where we switch the term in the middle. That will always happen. So in other words, we can really kind of skip the outer and inner part of things. Let's erase all that. We're really just going to multiply first and last. So the first terms and the last terms, because we know that when we multiply conjugates, outer and inner will cancel. So we could have just gone straight to having this, x plus h plus 2, minus quantity x plus 2. And then all over, let's do a big fraction bar here, all over h. Actually, missing a little part, or an extra part. All over h times, sorry, this part right here, right? This quantity, square root of the quantity x plus h plus 2, plus the square root of x plus 2. Now notice, I did not distribute the h in the denominator. And the reason is because focus on the goal. The goal is to simplify the h, the original h, in the denominator. I don't want to distribute it out because I want to get rid of it, right? Distributing it like makes it more embedded in the problem. So I'm going to leave the h on the outside. All right, what do we have left on the top? We have x plus h plus 2 minus x minus 2 all over that h, the one we're trying to get rid of, times the quantity, the square root of the quantity x plus h plus 2, plus the square root of x plus 2. These are long problems, unavoidably, I'm sorry. All right, now, in the numerator, some stuff cancels. X minus x is 0. 2 minus 2 is 0. So what I have left is just an h on the top, which is perfect. And then I have that h on the bottom that's being multiplied by that conjugate, the square root of x plus h plus 2, plus the square root of x plus 2. All right, now these h's cancel. H divided by h is 1. So another sort of common mistake here is when canceling, people will put a 0 on the top, but it's not a 0, it's a 1. Right? There's like a 1h here. H divided by h is 1. So what I have left here, what is the answer? Let's make some space. I have 1 over the square root of x plus h plus 2, and still in the denominator, plus the square root of x plus 2. So it's definitely messy looking, but we know we're done because we canceled that original h that was in the denominator of the difference quotient. So these take some practice. I would definitely focus on making sure you understand the first step of setting up the difference quotient, understanding those three parts, f of x plus h, the top left, f of x, the top right, and then all over h, that's the bottom. And make sure that you set them up correctly first, and then work on the algebra needed to eliminate the original h, which might involve distribution, factoring, combining like terms, clearing fractions, or multiplying by conjugates. And in the future, additional strategies may be needed for simplifying the difference quotient.